Okay, so in this video, our goal is to find the critical numbers for this function. And once again, it's important to recall the definition of critical numbers. So they're going to either make the derivative equal to 0, they're going to make the derivative undefined, and most importantly, they have to be in the domain of the function f of x. And that's a very important thing for us to check every single time. So to find this derivative, and therefore the critical numbers, we want to go through and use the quotient rule. So our derivative f prime of x is going to be the derivative of our numerator, which is 1, times our denominator, minus our numerator, times the derivative of our denominator, which is 2x. And of course, that's divided by our denominator squared. All right, so next thing to do is to simplify this down the best we can. So f prime of x is going to be an x squared minus 1 minus a 2x squared divided by x squared minus 1 squared. Combining like terms, our derivative is negative x squared minus 1 over x squared minus 1 squared. And at this point, it's kind of helpful for us to go through and factor our numerator. So in doing so, f prime of x is equal to negative x squared plus 1 divided by x squared minus 1 squared. So this is our derivative for this function, and you will notice that it is never equal to 0 because the only way that would happen is if x squared plus 1 equals 0. But x squared plus 1 is always positive. In fact, it's always greater than or equal to 1. So our derivative, f prime of x, is never equal to 0. And in the event that you wanted to set it equal to 0 and try to solve for x, you would get imaginary numbers in the case. And again, this is keeping everything to real numbers in Calc 1. Next thing to notice here is where is derivative undefined? Well, f prime of x is undefined at two different places, -1 and x equals +1. But neither one of those numbers is in the domain of our original function because they would have us being dividing by 0 in the original formula f of x. So even though those numbers make our derivative undefined, they are not critical. All right, so x equals -1 and x equals +1 are not critical numbers. Since they are not in the domain of our original function f of x. So very important to, again, observe the fact that when you have numbers that are not in the domain, they cannot be critical. That is the key, one of the key parts of the definition of being a critical number for a function. So therefore, there are no critical numbers whatsoever for this function f of x. And in upcoming sections, you will notice that this derivative is always negative, and therefore something that is always negative will not have a place where it has a horizontal tangent line. So again, our derivative is non-zero and is never undefined at places on its domain.